if the connection. Okay, now we have the connection. Okay. Um, Good morning again, and welcome to all of you to the first technical session of this year. It's always a pleasure to welcome you. This is the first technical session, as I said, of the series of VHL and LILACS 2025 meetings with MEDCARIB Network, a series of sessions organized by BIREME as part of its technical cooperation program, focused on strengthening health information networks in Latin America and the Caribbean. Now it's the 50th consecutive year, and we started last year with the specific sessions for the MEDCARIB Network. The aim is to enhance knowledge and develop essential skills for implementation and effective use of VHL products and services, in addition to strengthening LILACs and DECS. Today, we are gonna start with welcome remarks by Victoria Christian Taylor, who is the regional coordinator of MEDCARIB Network. And then we will proceed with the two presentations that we have today. The first will be the super abstracts delivered by Francisco Barbosa Jr. He is an AI specialist of BIREME. And then we will have Dex Finder AI delivered by Luciana Beatriz Piovesan Rio Branco, who is a librarian of BIREME. And we encourage all participants to engage actively, ask questions, and share insights to make this a productive and enriching experience for everyone. Okay, so welcome again, and let's begin. Victoria, the floor is yours for the welcome remarks.
Thank you so much, Marcia. Good morning and welcome to everyone. I'm so happy to see all of you here. And I want to just say thank you so much to BIREME for doing these sessions. As Marcia said, this is the first webinar for the year. And as with previous sessions, we expect that we would have a great learning experience. So what we're asking is that you take it all in, ask as many questions as you wish, so that we would all come away with more knowledge gained and a greater ability to do the work that we have to do here in the Caribbean. So special thank you to Marcia, BIREME, and the team as we continue to support knowledge sharing and management in the regions. Thank you, Marcia.
Thank you, Victoria. So now let's start. The first will be Francisco Barbosa Jr. We invite you to do your presentation, please.
Thank you so much, Marcia. Thank you, everyone. It's a pleasure to be here today. And I will talk about a little bit of super abstracts. I will share my screen. Let me see here. Share. There and share PowerPoint. I will put on presentation mode, and let me see if it will be correct, or we need to change the presentation, or we need to switch, or you are seeing the presentation view.
No, we are seeing your view.
Okay, switch displays.
Yeah, this is.
Okay, thank you very much, Marcia.
Thank you.
So let's start. We'll talk about super abstracts. Initially, an AI disclaimer here. It's part of our running AI activities, and we are starting to put this note, and because I use it so the artificial intelligence to organizing ideas, drafting and editing, but our content has been validated by me in this presentation. So thank you. And so what are super abstracts? Super abstracts, it's ultra condensed abstracts, 38 to 62 words. And this the important thing with the super abstracts is not a replacement, but just a fast reading lens for decision making, because we have a lot of articles and a lot of text, and we in the moment that we concepted the super abstracts, we are thinking to how can we make this fast. We have a lot of articles and we have the abstract, but and to became this like a tweetable abstract, smaller versions, and we are starting to work with this, and this is the motivation of the super abstracts. And why super abstracts? Because we have abstracts. Why do we need the small abstracts? Uh, Today we have the overload of information, cognitive fatigue. We have a need for rapid evidence-based decision making. It's very important, and responds to the increased preference for quick visual and mobile-friendly formats. Because now we have almost then 7% of the access in the internet in general in mobile devices. And if we have a lot of text, a lot of information together, it's best to have small versions for quick visualization and for rapid delivery of the information. And the technical structure of the super abstracts, it's actually very straightforward. Super abstracts, it's powered by in-house fine-tuned Llama 3B. It's a smaller scale from the LLM Llama family, because just a comparison. In the GPT from the OpenAI, the open version to the public, it's for like 400 billion parameters. And this we have a 3 billion parameters, and it's a smaller scale from an LLM. It's sometimes called SLM, a small model. And we use Olama. It's an open source framework for local orchestration, reducing the complexity in managing language models and support. And this is so important, with low overhead and cost-effective deployment. In other words, we use Olama. Olama orchestrates all the models, and we can run the different tests and different models, and the small models and big models. The Olama orchestrates all of this, and we runs all of this in Linux Ubuntu as an operating system. And our results and impact. We had a validation. We had an initial validation, and we had a high linguistic and semantic fidelity for the abstract. Now the super abstract have a high linguistic and semantic fidelity of the original and full abstract. And now it's visible on the VHL portal as a new metadata field. And with this, we have it, like I said, the time saving helps triage and prioritize articles efficiently. And I will show, I have a print screen. here. And I have a print screen with an example. I am actually at this time we are processing the super abstracts, and here it's an example in the production in the VHL portal, and here we have um, a study, and you can see my interface. It's in English, and the super abstract right below the right below the title, it's in English too. And when we click, if we click the view original abstract, we will go right below the original abstract. And it's interesting, it's important and interesting. The super abstract, box, we try to have the same language as the user interface. And so my user interface is in English, and the super abstract is in English too. But we have, if your environment is in Spanish or Portuguese, if it's available, we put the matching language. And if we don't have the matching language, we will show the English version of the super abstract. And always below in the button, if we click, we go to the original and the full abstract. And so the idea is to, here it's interesting to see in the same space, here we have one study in the abstract. And if we go back, we can have two, two titles. And with this in mobile devices and smaller screens and fast to show and to have okay, have the think of, I will see this paper or other paper, and okay, I choose this paper. Now I will see the full abstract, and this is the idea of the use of super abstracts. And about the ethics and the sustainability, we made of this in our local infrastructure in BIREME, and this is cost effective and scalable. Um, some of the presentations of AI uses, especially using LLMs, uh, the some developments are with the full models, with 400 billion parameters, 100 billion parameters, and this is very machine consuming, computing consuming, energy consuming. It's uh so big, charged model in the to do something that's sometimes not necessary to do this. And here is the idea that we, with a small version of an LLM, with the fine-tuning technique, we kind of teach it to this small model to, okay, you will be specialized and make abstracts and make the small abstracts. And we had the fine-tuning technique for this. And this is so interesting because we can use some a lot, or not a lot, but in our case, we have one model for each language, and we can use this in a lot of environments and situations, and it's interesting to use not a big model, to use a small and specialized model. Okay, in the beginning, it's a little bit more time consuming to adjust the fine-tuning process, but after we have very consistent and kind of a quick response of the model. And this is cost effectively because every computation that we have this costs energy, computation, and if we can do this effectively, it's best. And the challenge that we had and our lessons learned is in the fine-tuning process with balancing the creativity and the hallucination. We can adjust the name, it's interesting, it's the temperature. We can adjust the temperature of the model, and with this, we say to the model, okay, if you have this text, this piece of text maintains with this piece of text. Do not go to the other subject or suppositions or something that's not in this text. And for this, to achieve this, we lowered the temperature of our model. And this is so important to ensuring the scientific quality. Because if you have the super abstracts, and the super abstracts, it's display an information that not exists, that's not in the original and the full abstracts. This is very problematic because here we are talking about health, and we can't have creativity. And so to ensure the scientific quality, we adjust the temperature, and this is only possible if we use the in-house models, and we can adjust the models. We use some out-of-box models from the internet, because it's so simple to pick some ready model from some big tech and to use. But with this use, it's not a wrong use. It's not a wrong use. But with this use, we can't have the full control to the results. And especially this part, this is the temperature. And another very important point is the scaling. You can scaling without compromise control, because the only what do you need to scale? We need the computing capacity. If we have computing capacity, we can put our model and generate a lot of super abstracts. We don't need to go to change the technology to put this outside. No, just with the computational capacity, we can increase the capacity to make super abstracts. And our next steps in this project, we are running in our servers, and we are expanding the super abstracts to the VHL, the all VHL collections, and this will be added in some like let me see how much we have, kind of 1,000 computations every day, and we need some adjusts the processing and the computation, but in the raw numbers, it's like 1,000 new super abstracts per day we are processing, and we'll put this on the VHL connection. And we will do some another formal evaluations to the model, to the metrics, to compare with another models to the summarizing models. And we have these two techniques, it's bleu and rouge, to calculation the accuracy of the summaries. And we will explore the full abstract generation based on complete article texts, because the super abstracts it's because it's running. The super abstracts is the first step to understanding the full abstract generation based on complete articles. And we are studying, we are training models, experimenting models, and our first deliver of this is the super abstracts, but we are working in this full abstract generation, and that's all. So thank you very much. I'm here to respond your questions. I am not seeing if you put something in the chat, but I think after I will stop share. I can see if you sent some message, but I'm here after the presentation, and if you want to contact me, feel free to contact me. And so thank you very much.
Thank you, Francisco. It was a very, very interesting presentation, and hope we will have many questions about that. We will have more the next presentation, and then we will open the floor for comments and questions. Okay? Thank you. And now we will have Luciana. Please, your presentation. Thank you. Luciana?
Hi. Well, good morning, everyone. Thank you, Marcia. I'm gonna share my screen. Okay, I was putting the presentation in the correct mode. I can see that it's been shared and it's in presentation mode. Okay, correct? Okay, thank you. So my name is Luciana. Good morning, everyone. I would like first to say thank you for the opportunity and the pleasure to being here in this MEDCARIB meeting today, the first of the year. I'm very glad to share this brief presentation about DexFinder AI. It's a project that I'm very happy to participate, and we expect will bring innovation to the way we work in the organization of knowledge, of scientific knowledge especially. So this tool was developed to address the challenges of the indexing in health scientific literature. It's a context we know that precision and, of course, scale and multilingual needs are critical. And much like my friend Francisco, I have to say that I use AI to prepare this presentation, Gen AI, to help me organize my ideas, but all content was reviewed and validated by me, and I hope you all will get all my points here. So the DexFinder AI, it's addressed to the challenges of automatic indexing. Indexing is a tool for information retrieval, and it's often made by manual indexing. It's a process essential to the process of organizing knowledge in databases such as LILACS and others, but is also a very time-consuming task. It's hard to scale, and it needs in its specialized resources, which is human resources to index documents. In this task, indexers, they must quickly recognize and adapt to new topics and new descriptors. They need to understand the articles, the documents that are often complex because it's science, of course, and it's a domain that is not natural for librarians. We are information professionals, and we usually work in other areas, such as health, and we must understand what is being said in documents that are not from our base of knowledge, and we should do this to make sure the relevant aspects of those documents are represented in catalogs. It is a task, as you can see, and of course, as you know, is a very hard task. That's why we are working in trying to automate this task. At this moment, we still face difficult challenges for automatic indexing. It's hard for the machine to interpret complex semantic contexts. It has many limitations for controlled terminology, especially in documents that present a multidisciplinary content. It's difficult to ensure precision, especially in comparison with specialized human indexing. There's a need for constant updating of the indexing models. They need to maintain relevance. They need to maintain to be updated with terminology. And, you know, DEX, for example, it's updated yearly, and that needs to be reflected in the model of indexing. And the model depends highly in the quality of the training data. As you know, inaccuracies and inconsistencies will affect the effectiveness and the reliability of the automatic indexing. So that was our challenges that we're trying to overcome. Index Finder AI, it's a tool tailored to meet the needs of the Latin American and Caribbean social-cultural contexts, which means it's not just a copy of other softwares for automated indexing. It's, of course, a AI-powered indexing tool. Is specialized for the scientific literature and designed exclusively to work with DEX. And that, per se, addresses the challenges of the linguistics and also the challenges of the diversity in the thematic diversities of our regions. DEX has 5 categories exclusively for DEX that are not present in MESH. And those categories are meant to work with the subject aspects that are important for our region, such as public health, such as sanitary vigilance, surveillance, and this means that XFinder AI it's also trained to work with those subjects. We initially launched Text Finder in 2021 with a simpler algorithm that it was a natural language processing algorithm. It's called X Highlighter. And this algorithm was only lexical, which means it could only identify words that were written similarly in the article and in the text, including, of course, descriptors and their synonyms. In last year, we advanced this model with other AI models and with a training directed to meet the needs of the LILACS methodology. This new model was first launched in December of 2024 in a beta version, and last month it was updated again in a more non-beta version. So I think I didn't pass this slide. So our main goal is incorporate text descriptors into bibliographic records through subject indexing in the database processing, which means our goal is to have a fully automated indexing within FEI admin. And for that, we're taking small steps. The first step, as I said, it was launched this model in the Text Finder website as a semi-automated indexing feature, and also the integration of this Text Finder tool within FE admin. And now it's still in a way of semi-automated indexing, but already having the AI functionality. We think the user benefits in this with this tool, it's first the time saving, because it accelerates the process of cataloging and analyzing the texts. The identification of emerging descriptors, because as I said, DEX is updated yearly, and it's not possible for us as humans to know all the terms in DEX, especially the newer ones. So when you have a tool that identifies descriptors in your text, it often suggests terms that you wasn't aware that they existed in the vocabulary. Also, it's accessible to a diverse group of users. We're talking about mainly the librarians, but also it could be used for authors and other academic researchers when they're posting a submission to one scholar journal. They can use this tool and identify the best descriptors to use as keywords in their submissions, and also to identify descriptors for a better search in our databases. As I said, there's the integration within FE admin platform, and of course, it enables the semi-automated indexing in the support of the results that I already said. I would like now to show you how to use those tools. There is two ways of getting to the website, Dex Finder website. One is through Dex itself. So yes, you're seeing the Dex website. There's a link here for Dex Finder, and this page is in Portuguese because the the system recognizes the interface language, and when you use it, it will probably recognize that it's English, and you'll see the English page. There's here a few information. You can click in Try It Now, and there's two options. One is for beginners. It's use supported by the mechanism, and the other is more direct use. I'll start with the beginners. There's a kind of a wizard here. It will ask us, it will conduct us in the using of the system. So the first question is, what is the language of your text? There's a few options you put. So I would select English, and there's an option to paste, of course, your text. I have already prepared here a text with a title and the abstract of a article. There's a few other information, but those aren't needed. But you can always tailor the text the way you want. If you want to put more than the abstract, like the methodology or some parts of the text that you feel it's more important, like labels from figures, from tables, or the results, you can just select and paste in the box. Click on Next. There's another box to select in what language do you want to see the results. I will just put the same found in the text, but if you're working with maybe your Spanish or Portuguese articles, you can select a different language to see the results. So I'll select the same found in my text. It's an option to filter more. I will just say no and proceed with the analysis. And I'll get a page showing the text that I inputted and the descriptors that were found in my results. It's important to see that the order of the terms appearing here in the suggestion box is determined by the probability of them being adequate for the indexing of such content. It doesn't mean that this is, for example, the primary descriptor that should be used in the LILACS methodology. It's just a probability. So when the results are shown, it's important that you analyze those results to check that they make sense for the content, they fit the content. For example, we have here incidence. It automatically shows the scope note of this descriptor index and the codes for hierarchical codes of the descriptor. If I click here, I'll open the descriptor page index where I can find more information about it. And for example, the annotation, which is information important to see. How can I use this descriptor in indexing? I can have all my results here. I said that is the example that it's important to analyze all the descriptors and the scope notes because, for example, drainage, here it means the removal of fluids or discharges from the body. But we know this word drainage, it can be used in different contexts. For example, in urban planning, and it means a different thing. So we have to check if the scope notes are similar to the aspect of the text before selecting this concept for indexing. In the box where I have the full text that I inputted, there's also another terms that the system found here that are descriptors. It's important to also analyze those. Maybe I think that something that is here, it's more important that the descriptors that were suggested in the box of results. I have an option to open more the box to facilitate my reading. I can also change the language of the terms or no, and of the texts up here in those boxes. I have a few more options here, and I'll just clean to show you. This first button here, it's for importing a file. Actually, we're working with PDF files. So I have an article here to text. I select it, and the text is being analyzed. It takes a little bit more time because of the larger quantity of text in the article than in the result, the abstract, but usually it doesn't take much, and we'll have the results for our we have the results for our analysis. It also have the text, full text, and the same as in the abstract. I can read and analyze better the text and the options that the system understands better for this article. If I like the result, I can just click here on export file. It will have a text file option that I can just open or save. I'll open here, and it has all the descriptors and the descriptor ID, which I can use to find them in index. And I can see there's a lot of, because it's a full text, and I can just add it here or use it in different databases, for example. If I think there's something wrong with the system, or I want to make a comment, make a suggestion, there's a button here for send your comments. It will open a menu where you can fill in, is the same as the others in the VHL, and we'll receive this message and respond to you. It's very important for us to have all the feedbacks you can give us. Now I'll show you how to use the text finder in FE admin. I'll already have the interface open here. So when indexing, we'll go to bibliographic records. I suggest I will select the records of my center. For example purposes, I'll use something that is in LILACS Express. Okay, and then I'm analyzing this article. I'll be completing his indexing. It's important that the metadata contains the abstract of the article. And in the indexing window, you'll see descriptor suggestions. Once you click, this window will open, and here you have the suggested descriptors for this article. If I think those are correct, I can add them and choose if I think according to the LILACS methodology it's a primary or a secondary descriptor. Let's say I think it's the primary subject, and it was added to the indexing of this article, to the metadata. It's also important, as the same as in the other option in the website, it's always important to check, to confirm in the scope note, to confirm in the text if these subjects are adequate for the text for the article. But we think it's a very improved system that we have now. And I show you how to use it in the DEX. There's also here the link for the direct page of DexMinder, which will go to this page. And well, if you have any more doubts or questions, feel free to contact us. And I think that was it, Marcia. Thank you very much, and thank you all.
Thank you so much. Also, very interesting presentation. And sure that these are themes that are challenging and sure make us all reflect about the future with AI. What's going to happen to us and to all, not only as persons, but as the information products and services, how we are going to improve them using the AI as a tool for us. Okay, so thank you again. Very, very interesting presentations from both of you. And now we open the floor. If anyone have any question or comment, please feel free. Thank you.
I am looking for the raise hand button and I'm not seeing it, so I'll just jump in. I must say that I love the innovation. I think that these tools are very helpful, and I'm sure the catalogers among us are happy to see them, as they would certainly help to make their work much easier. I remember the session, we had a session last year where we looked at how using ChatGPT and such for indexing, and we saw that it wasn't a good fit, right? Based on the report that came back. And I'm happy to see that BIREME did develop something that can help with the AI finder. I wanted to ask though, with the super abstracts, does the tool also, is it also used to synthesize documents? So can you put a number of documents together and get a fresh look? Is that one of its uses, or is it only for the super abstract? And also, I wanted to know if persons think that they can use like Gemini or Perplexity or one of those ChatGPT or one of those tools to do super abstract. Is that a good thing for them to consider?
So thank you very much for the question. This question it's very good to all the mechanism that it's based the super abstract. And so for the first question, it's not possible to use the model the super abstract model to synthesize full texts or completed big in general big amount of text. We can't use the model. This is so interesting because when you put in our tests, when we run the super abstract model and we put in the model big text like a full article, the model starts to hallucinate. It starts to not the answer. It's not an abstract. It's not a summarization. It starts to hallucinate, and this is interesting because it's a signal that our fine-tuning worked, because we did a fine-tuning to with the fine-tuning we put a abstract, and the response to the abstract and small no, the super abstract, and we put a lot of these examples, and with the abstract in one column, a lot of abstracts, and the another column, the super abstracts. And we fine-tuned this with like 120 epochs, the iterations with the models, and the model really really adjusted adjusts the sizes inside the model, the in the how can I say this? They adjusts the parameters of the models to work only with the abstracts. And because this is a small model, when we put a lot of context, they didn't understand. And for this to go to our next step, we need a new model. Probably we will use, instead of Llama, that it's an open source model that we use today, we will change to Phi. Phi is from Microsoft, created from scientific articles, and it's 14 billion parameters. Our llama is a 3B parameters, and we probably, because we need to run some other tests, we will change the model to the Phi, a little bit bigger model, because with this this model will be able to understand and get a better context to the input. If the input is a big quantity of text, the output will be acceptable small quantity of text. And the second answer, and these models that you said, the Gemini, the Perplexity, and they are not an open source models, and we can use, everyone can use, like the GPT, the Gemini, can use these models, and the results, it's actually very good results. But we can't put these models to run automatically in our environment. And these models, to use these models, in a API format in our environment, this will cost, because they charges, every model, every company charges in a different way, but they charge with tokens. Every token is like almost every 3 or 4 letters, it's one token. And these models, they charge, if you use tokens, they charge with each token to the question and the answer to the model. And so it's possible to use other models. They have a very interesting response, but it's the price is high. And this is sustainable alternative. It's to run in an open source model in our environment with control of the temperature and other parameters. And this advantage to use this, it's because when we fine tune it and when we lock and adjust the model will always work like it's expected. And like today, the super abstracts model they will work differently only if we change some parameters. If we don't change parameters, they will work in flat. Okay, if you put abstracts, they'll give you super abstracts and just it. And if we use an API for an external model, we don't know if this model changes. It's possible to give another answer, not necessarily a wrong answer, but an answer that's not expected. And this we lose some control in this. And this is the pros and cons to use the different models and different approaches. Thank you.
Thank you. Thank you. Another question or comment? No?
Yeah, so I had another question about the
Sure.
quality control measures using the AI Dex Finder AI. So I know that we usually say we don't want to use a whole set of terms, especially if the terms become so granular within the within the documents. And I noted we can get a lot of terms based if we upload. That's one thing I was glad to see, that we can upload the document for AI to be able to read it and generate the terms. But I wonder that the quality control measures to ensure that we get the best terms, or is it that we are the control, the quality, the human factor is the quality control mechanism for that automatic indexing? Yeah.
Yes, thank you, Victoria, for your question. In this presentation, we didn't include many of the process of building, developing this new version with AI, but the quality control is included in all parts of the process. First, because we use as training data the records from the LILACS database, which means we selected not like the LLMs like ChatGPT or others that use all the content in the internet to maintain the base of knowledge. We used a very controlled set of articles of data. This set of data was validated first because it's from LILACS database, is indexed manually by LILACS indexers. Second, we made a filter. We chose a set of indexers that they were considered, I wouldn't say best, but I would say more familiar indexers, familiar with the methodology and with DEX. And we selected articles indexed by those experts indexers to create a training set. This training set in English, it includes 7,000 records that the model used as a learning base to understand how the LILACS methodology works and try to replicate it. So this first step is a step of quality control. We didn't want to include any kind of data in the training so that the system would learn how to index anyways. We wanted to to meet the quality of the LILACS database. It's important for us, this consistency and the similarity of the work. Second, the system has a set of metrics for evaluation the results, and this metric is automatically calculated. We are now in a kind of 50 approximately 50% of this is a rate of writes, a rate of the system is doing correctly. It's meeting the precision of the LILACS methodology, and we use those, especially those three metrics called precision and recall, which are well known for us librarians, and also a F1 score, which is like a equalization of the precision and recall metrics. And only when we realized that these metrics were right, we're in a good position, we started to think about putting the system on air. And also we did a round of empirical evaluation with the specialist from BIREME, which included me, Francisco, Sueli, and others, to see if we could feel the results were close to correct, how close to correct they were. And we all have a good feeling also if from this new, especially from this new model that we put in public last month, this new version. But of course, as we said in the beginning of our presentation, we're using AI for many things, but it's necessary at this point that we understand that we are responsible for the results of our work when we use AI. So the main quality control, it's still the human indexer that is using these tools. We have those like barriers to not allow the bad results to go to the screen, but still what is inserted, what is assigned in bibliographic records, it should be with the full responsible of the human indexer. We're at this point we can assure a tool for assist the indexing, not yet for the automatic indexing. We hope to get to this point, but for now, I would say we are still the main quality control.
Okay, great. Thanks. And I just wanted to know, I know a lot of people will go away hoping to use the tools, and they may not remember. Is there on the website, is there anything that shows you a step-by-step of how to use, or a little demo or anything like that? Or is it just so simple we will remember when we get there?
Yes, I think it's very simple, but the wizard that I showed in the beginners users mode, it's already this demo version. It's like a step-by-step way of using the tool. And once you get comfortable with the system, you can always go directly to the advanced users. That is a more direct interface. But I think also this presentation it's being recorded, so we can always make it available.
Thank you so much.
And Sueli put in the chat the link if you want to try. And I want to, I don't know if you don't have time, but just 2 minutes. I just want to add some words about the Dex Finder. It's because that I personally loves the words. I love the Dex Finder solution because we have a lot of LLMs use, like all these examples, the ChatGPT, Gemini, Perplexity, a lot of models, and this is super abstract too. This use LLMs. And LLMs, by design, they can hallucinate. We can adjust some guardrails to not know the word, to reduce hallucination. But they are LLMs, and LLMs operas by probability, and the probability in the entire training, entire initial training, and the downside of this big training with a billion of parameters, it's the hallucination. And the Dex Finder, we don't use LLMs. We use the uh, other side, other style of AI, that it's NLP, it's natural language processing. And in the NLP, we have training, not fine tuning. In LLMs, we do a fine tuning here. And with the NLP, we can do a training, and that was done in the DexFinder AI. And in the training, we put the Dex database. And so this is a huge difference from use the ChatGPT or some LLM solution, because the Dex Finder will show to you only the Dex terms, because it's the Dex Finder, it's trained to, okay, I just will use this database, the Dex database. And with this, we cut a lot of problems, because with an LLM, they can invent terms and, okay, this term and this term, but the term, it's not exists. And it's not useful because it's not in the Dex database. And with an NLP, the Dex Finder, the Dex Finder construction, they the Dex, it's restricted to the Dex database, and the results can be wrong, of course, because it's the we are evolving constantly the product, and evolving, and like Luciana said, we are using and adjusting the F1 score and testing, but okay, some response can be wrong, but it's in the Dex database only. They will not invent the terms, and will not hallucinate, and this is a huge step uh, uh, to go to the correct indexation, to choose in the right database, and we are evolving the system. The two systems, the super abstracts and the Dex Finder, we are evolving, continually evolving to adjust the scores with the fine tuning in the super abstracts and the training in the Dex Finder. And we are in the Dex Finder, we will increase the corpus of the training and to adjust, and to we will have sure that we'll have the best results soon, and we are going. And this is it. Thank you.
Thank you very much. All very interesting aspect.
maybe we have problems with internet connection, not only for Marcia, but for other BIREME members. I'd just like to thank you all for your participation. And thank you, Francisco and Luciano. Oh, sorry, let me open my camera. Okay. So
Sorry.
here again.
Sorry, I don't
Okay.
know what happened, but I lost the connection. Sorry.
Okay.
Okay. So
So
thank you.
take the floor again.
Thank you. Thank you. So we thank you very much for all the presenters. Thank you very much for all the insightful information and all the challenging aspects of the use of AI in everything that we do and in our life. Okay. So maybe we can open the camera if we can, just to take a picture. Thank you, Victoria. I don't know if more people can open the camera. Okay, so maybe just, oh, they are opening.
Yeah.
Okay, so maybe we can take a picture. Okay, so thank you very much for your participation and looking forward for the next technical session. Thank you and see you.
Thank you.
Bye,
Goodbye.
everyone.
Thank you. Bye bye.
Thank you.
Bye.
Thank you. Bye.
Thanks for having us.